So if you have cosecant and cotangent plus secant equals secant over sine squared, I change everything to sine and cosine, and it ends up being 1 over sine, cosine over sine, plus 1 over cosine. And then I combine the left fraction, and I get that that's equal to cosine of theta over sine squared of theta plus 1 over cosine of theta. And down here, I found a common denominator. I combine these two. The left side needs a cosine added upstairs and down, and the right side needs a sine squared added upside and down. And when I combine that, I get cosine squared plus sine squared over cosine sine squared. Well, the cosine squared plus sine squared turns into a 1. It's a Pythagorean. And then I move the cosine upstairs and make it a secant, and I'm there. So number 12 says secant squared of x over tangent squared of x equals cotangent squared of x plus 1. So on this one, I'm going to work with the left side a little bit and turn that into one thing all in cosine and sine. If I have secant squared of x, I'll leave that upstairs. I'm going to move this tangent upstairs if you don't like a basement and make it a cotangent squared of x. Does everybody understand that? If you move it upstairs, it turns into his cousin. If you move it downstairs, it turns into his cousin too. So this would be 1 over cosine squared of x and cosine squared of x over sine squared of x, right? And that's equal to, the cosines are going to bite the dust. 1 upstairs, 1 downstairs. You follow me? Mm-hmm. And that's 1 over sine squared of x, which is cosecant squared of x. And if you look on your formula sheet in the Pythagorean side, we know that the cotangent squared of x plus 1 equals cosecant squared of x. This one equals cosecant squared of x. So we are there.